Okay, guys, so I wanted to record part 2 of Dalton's Law, right? So part 1 talks about when we combine two individual gases together, as long as they do not react with each other, okay, we should be able to take their partial pressures and add them up to get the total pressure of the system if we combine them together. Now, the second part of Dalton's Law is a little more complicated, and it has to do with the way that we collect gases. So we collect gases in a system over water. And I'm sure you guys heard that and you were like, I have no idea what the heck you're talking about. What you mean over water? Let me give you an example. So the way that we measure gases is going to be using a system of displacement. Okay, let's just give you the uncomplicated version. I'll give you a great example. So I have a container of water that is almost full. I take a rock and I throw it into that container of water. What happens to the level of water? I'm hoping that you said that the water level would be higher. What that means is that the rock displaced a certain amount of volume that was equal to the rock's volume or mass. All right? So in essence, what we're doing is we're trying to figure out the pressure of a particular gas, but we're doing it over water. So when we do it over water and we do this displacement, right? In our example with the rock that we're dropping into a container of water, the rock is what is going to account for the additional volume of water. In the case of Dalton's Law, because we're collecting gas over water, when we run the experiment, we collect water, great, but we also collect our gas that we're looking for. So when we're talking about the total pressure of the system is going to be the partial pressure of the gas that we're looking to collect, but then also the partial pressure of the water that came along for the ride. So in essence, to figure out what the total of the system is, we would have to know what the partial pressure of the gas is and the partial pressure of the water is. Now, for the partial pressure of water, you have a table that is in all of your notes. Okay, so basically what this is telling you is it's giving you a temperature in degrees Celsius, which is really important to remember, okay? Because up until this point, we've been converting everything into Kelvin. Unfortunately, for partial pressure questions, you're going to need to convert your Kelvin back to Celsius. Most of the problems that I'll give you will be in Celsius. The other thing to remember is that all of your pressures need to be in millimeters of mercury. So if you see it in anything else, then that means you're going to have to convert to millimeters of mercury. Basically, it's giving you a temperature reference with a pressure. So it basically says that the vapor pressure of water at, let's just take the first point, at minus 10 degrees is going to be 1 millimeter of mercury. On the other side, if you take a look at some of the higher temperatures, it is telling you that at, let's pick the 80-degree point, that it is going to be 355.1 millimeters of mercury. The reason why this is important is because we are going to use it in our equations. So because you know that the total pressure of the system equals the pressure of the gas that we're trying to figure out, but then the pressure of the water that came along for the ride, right? You should know when you are rearranging that equation that if you were looking for the pressure of your gas, you're going to need to take that total pressure, which is normally given to you in the problem, but we'll talk about that in a minute, right? And you're going to have to subtract the partial pressure of the water that came along for the ride. Okay, and that's how you would figure out the partial pressure of your gas. Right, hopefully that was helpful, a little bit clearer. The next videos, I'll be walking through some of the problems on your worksheet, just reinforcing some of these ideas.